A lot of companies are using computer vision for, like I know one for real estate, monitoring of progress, other one for monitoring of the stocks in the warehouses, and then the NLP, natural language processing, where Google has a lot of innovations already done. Voice assistant is already being used by many of us in a practical way. Today, especially in the global multinational companies, translation is being used from Google AI, and that makes the life very very easy. All documents, all things can be converted without much effort. But the real one, which is going to be useful for large enterprises, are related to the deep learning. Data engineering is another, very good area which we have to deep dive on. And because of my SAP's experience, all the sources of data, how the data is managed, how the data is cleansed, duplications, null, data, and filling in the missing data, all of that, being part of the data engineering pipeline, I can help with. And once the clean data is given to the machine, it is to be split into the test data and the training data. And once the training data is, found the algorithms, as I said, deep learning has very, very complex algorithms there, but we are not going to do the heavyweight lifting. Most of these are algorithms available from libraries like TensorFlow and OpenCV and Spacey and all of that, and we can just use those library functions and make our applications work. And with that background, as I said, I could help you in building up machine learning applications. Especially, I'm diving into the applications which can be used in the enterprises. For example, success factors. It's HR application from SAP. It can cater to anything from recruitment to finally, of course, employee database, and finally learning and compensation and succession planning, etc. But where the machine learning comes in is that today there are components available in the machine learning which can be plugged in to identify the talent available in the market to match the job requisitions we have. So that those components are using the TensorFlow libraries, and they will actually be using a deep learning network, like convolution and recurrent networks, and these are very very useful because they can match thousands of job requisitions with hundreds of thousands of resumes, and these are very useful for large companies where it was to be done by the recruiters. And then onwards, of course, the SAP SuccessFactors itself has a lot of processes for automation of the entire recruitment process, having the job requisitions, their approvals, their interview, matching, which is where I'm saying the machine learning components can be plugged in, and that matching today was being done by the recruiters themselves. And then later on, scheduling interviews, taking feedback of interviews, and then, based on the selection criterias, making offers and bringing them and running with the onboarding process within SAP SuccessFactors. So if you see, there is a one side of SAP enterprise application which I can help with, and second side, how do we plug in the components for machine learning, components for IoT. For example, in the SuccessFactors, we have our devices where employees walking into the company need not punch any card or need not even enter anything. There is a face recognition camera which will, while entering, they will match it with their internal, employee database, and they will make the, employee present, or while coming in, mark the attendance in, while going out, mark the attendance out. So those are the kind of things which where I can help, and also going further, in terms of the success factors, HR, payroll. Each component of payroll comes from the compensation plans, and then executing the payroll every month, even retro, payrolls, and finally posting it to financials. That's another area where which cost centers are allocated for each employee, posting those cost centers, and then finally doing the GL postings to be able to do the financial reporting. Classic, machine learning algorithms which I have been using for small applications has been about regression and classification and clustering. And some of them, they have been part of the standard libraries from various, OpenCV, Google, TensorFlow, etc. And these are like, support vector machines, random forest, decision tree, and those are largely for regression. And as classification is also called statistical regression because it just classifies those data. And then clustering, which is like unsupervised learning. There we have again k-means and mean shift and Bush kind of algorithms. Although these algorithms are quite complex, and but there is a high level of understanding, and then libraries are available to call those functions in these libraries. And one of the key parts today in the machine learning, which I have been finding a lot of work is involved, is data engineering. So right from identifying the data sources and deciding those elements which are used, and finally cleaning up the data, a lot of duplicate data and a lot of null data, a lot of data to be filled in. And then for a learning or a little bit of experiment or test kind of a thing, we can use maybe a few thousand records, but in real life the data will be a few terabytes. So that takes time in terms of being able to even manage the data and then clean the data, having the right sources of data. And this part then feeds into the machine learning. What we call is training the machine. Firstly, we'll split the data into training and the testing parts, and then once these results are coming out of the machine learning algorithms are identified, we apply something called confusion matrix. So now confusion matrix may look to be a very simple thing, but it's actually the crux of testing these classical machine learning programs. Why? Because we want to see how many true positives are there and how many true negatives are there in the confusion matrix. So those are the correct results of our algorithm. But really we need to fine tune various parameters to make it what are the false negatives, what are the false positives, and based on the real life business requirements, business application needs, we need to minimize one of them, either the false negatives or the false positives. So confusion matrix again is part of the many libraries. We need to just call that function and it will provide the data. But then based on that, we need to fine tune and do a iterative process. And especially if you're using neural networks, then the backward propagation and forward propagation parameters need to be fine-tuned based on this machine learning algorithms. So those are some of the complexities involved here. And as I said, we would use it in a practical applications. Today, I specialize into SAP business applications and also Salesforce business applications. So those, especially Salesforce applications, whether it's for sales or it is for service or for marketing, or for e-commerce, each of these cloud application has a plugin. So we can plug in an area where the machine learning programs have been created and tested. They have been trained the machine, and then they will be used in the real life for sales forecasting. For example, service. They will match which engineer, for example, for Whirlpool should go to which machine to be attended based on multiple parameters. So it's like a resource allocation, resource planning, engineers allocation, engineers planning and services. And same way, as I said, in sales, one of the big applications with machine learning can be there in SAP C4C or in Salesforce is this prediction. So prediction of, let's say if we are talking about mobile phones, predicting the sales forecast numbers for the next month, next quarter, next year, etc. And as I said, there's a huge amount of data, unstructured data, especially in the life sciences, medical applications, X-rays and ECGs, and all of that data is also handled by these machine learning applications. So we need to look at how the data is sourced, and especially the unstructured data. Of course, the enterprise application will provide structured data like SAP sources. And then later on, we need to take that data to go through the cleansing And a lot of these, AI machine learning applications and libraries like NumPy and Pandas, they will help us to manage handle the arrays in NumPy and manage the data frames in the Pandas. And of course, we can also look at some of the analytics of this data so that we can also, fine tune it before being fed into the machine learnings. And that is done by visualization like Matplotlib. And all of these are, as I said, available on my GitHub. And some of the very simple ones, as I said, I don't claim to be a technical programmer, but I do understand it enough to be able to manage the program, manage the business outcomes, drive and align the executives on the senior executives on what they are looking for, what are the real bottlenecks in terms of technology, and accordingly put the right resources behind it. That's my area of help. Thank you.